All right. I've come by and marked off homework. So page 7, 8, we should be set with. Was there any last minute questions just from page 7, 8? Any last minute questions from 7, 8? We're just still getting it. A couple of you still doing the quiz, but I gotta go.
34.
Number 34 from page 7, 8. Okay. 34. All right. 34, let's see, that's negative 5x plus 4 quantity 3x minus 7, right? Okay, so we're not solving it. We talked about yesterday why we're not solving it. Why is that? There's not an equal sign. That's the big indicator. So don't go, oh, they made a mistake, go put an equal sign. No, don't. Okay? Huge error that takes place a lot of times in math. It's like you think, oh, a mistake was made, and though mistakes could be made, a lot of times you just need to combine like terms. So on this particular one, we're going to distribute over the parentheses. Get that, and then I add these two like terms, so that gives me 7x minus 28, and that's all done. That should be at 8. Okay? And then get out page 7, 8, 9, and 10, and I'll come back and mark you up. Was there any other questions from page 7, 8 that are sticking out right now? Raise your hand when you get those sheets out. Yeah? 29. 29. You're all right. Oh, okay. Number 29, we have 6 x minus 9 plus 4 x minus 6 and plus 23x plus 9. Okay, this is one that we have to make sure we distribute over the parentheses first, and then we'll combine like terms after the fact. So that comes here and here, so that gives me 6x minus 54, I believe. And then I distribute here and here, so that gives me plus 4x minus 24. And then I'm just going to bring these down. Nothing's going to happen to them right now. Is that all right? You got it done? Ready? All right. I do have like terms. Let's see. Like term, like term, like term. So 6x plus 4x is 10x. 10x added to 23x. 33x. I love it. And then I have here and here and here that are all like terms. So negative 54 minus 24 is negative plus negative 69. Okay, I like that. So plus negative 69. And then for a reduction in signs, it's totally cool if you write this. Means the same thing. So it's your choice how you want to write it. Is one more correct than the other? No. Okay? So it's your choice. But the problem sometimes with plus negative, sometimes you might start forgetting the sign, especially if you're carrying it through to other problems.
33x.
Oh, 33. Thank you. Oh, yeah.
Yeah.
Yeah, I dropped off a 3. Okay? So we set on 7, 8. I feel pretty good about it. If you have other questions, then ask about me at a different time. Okay? So now I want to go to page, what? 10, 11, 9, 10?
Yeah, 15,
Okay.
16, 15, 16.
15 and 16. We're there. I like it. Okay, both 15 and 16, they're four-sided objects. It doesn't matter the shape of a four-sided object. But they tell us that this angle is 110 degrees. This one's 90 degrees. That's a 90. They tell us this is unknown. And then this is 80. But in the instructions, they say the sum of the angle measures of a quadrilateral. So quadrilateral, for your terminology, is a four-sided object. And they tell us it's 360 degrees. So everything here has to add up to 360. So we are indeed solving. So this is what they're telling us. If I were to take those four angles, they're going to add up to 360. Does that make sense how I've presented that material? Yeah.
So, this one is 60 or 50. So, do you just do x equals?
Yeah. So we are definitely solving. So there's information they gave us in the instructions which said, hey, it's a four-sided object, quadrilateral. All four angles have to add up to 360. So this is like one side of the problem, which means let's take care of these like terms first. So that should be, I think, 280. Does that make sense? And it's still equal to 360 degrees. So this is a one-step problem, but there was an additional kind of step to do first. Yeah. Yeah, absolutely. So remember, now we're solving it. We can do one of those Jim Dandies, which represents the equal sign, right? And so I'm going to subtract 280 from each side. That is exactly correct. And x is equal to how much? 80? Oh, cool. So put your x equals 80. Make sure you mark it because it is in degrees. Okay? You could also then put that up in here if you want to do that. It's your choice what you want to do with it, okay? And number 16 is going to be done the exact same way. So you'd have x plus 125 plus 132 plus 72 equals 360. And you'd be able to solve it. What'd you get on an answer on that one?
On which one? 16?
16.
I got x equals
131?
131.
131? 51?
I got
31? 31? Okay. I don't know. I didn't work it out, so that might be true. So that should be, just give you a choice. It's done the exact same way. Yes, sir.
Can we do 17 and 18?
17 and 18, absolutely. Is there anything else from page 9, though? The first page? Yeah. Number 10? Okay. So let's just focus on that, and then we'll go back to those, okay? Number 10, we have negative 8x is equal to negative 20. Is that the correct one? All right, so what I want to do to both sides, how are negative 8 and x being held together right now? Multiplication. So I'm going to put my big old equal sign thing, right? All right, so they're being held together by multiplication. So I'm going to divide each side by negative 8. Is that correct?
Yes.
So that and that cancel out, and then that becomes positive, right? And then that makes that positive, yes? So I get 20 over 8, which is sweet, but the problem is you have to understand I can reduce that fraction. I think 4 goes into both. So 4 goes into 20 how many times? 5 times. 4 goes into 8 how many times? 2. So 5 over 2 is the correct answer. I like leaving it as improper. If you give me 2.5 or give me 2.5, totally chill. Good answers. Okay?
Cool.
Yeah.
Number 8.
8. Number 8, negative 3. Did I write that correctly?
Yes.
So the variable on this one just happens to be on the other side. Totally okay. So how are x and 6 being held together right now? They're being held together by division. So the opposite of division is multiplication. So I'm going to multiply both sides times 6. That would cancel that. So I get x is equal to negative 18. Remember, I have to multiply those. Okay? Can I leave the answer like this? Absolutely. Some people feel a little bit more comfortable flip-flopping it. You choose how you want to leave it. I understand it both ways. Yeah. I'm getting there. Anything else from page 9? 17 and 18 will be done. But anything else from page 9, that front page? Yeah. 14. Ooh, that's a good one. Number 14. I have x minus 3 over 7. Equals 4 over 7. Is that right? So this is one that we need to think about. The nice thing is we have the same denominators. The bottoms are the same. So there's something I will eventually start getting to on this type of problem called clearing the denominator, but I don't have to get there yet, okay? But I just want you to know that, and the reason I'm not saying we're going to do something called clearing the denominator yet is because both denominators are the exact same. So how is x and minus 3, 7 being held together? Subtraction, what are we going to do to both sides? Yeah, we're going to add 3 7s to both sides. So we're going to do that to both sides. So now we're going to add 3 over 7 to both sides. And the nice thing in this case is we have the same denominator. So I'm going to go 4 plus 3, which is 7. So I get 7 over 7, and that reduces to what? 1. Awesome. Awesome. Did that make sense? Good. Anything else from that page 9? All right. We are solid. Let's get to number 17. Let's see what number 17 talks about. Excited. It looks like a story. Okay. For problem 17 and 18, here are the directions. It says, read the problem carefully. Oh, okay. And then letter A, define variables. Set up a one-step equation. solve the equation, so we're going to look for our variable, and then write a complete sentence describing the answer in context. Oh, man. Okay, so problem number 17. Oh, it's a story. I can't wait to find out what the solution is. We get it. Oh,
Love when we mix English and math together.
Crystal wants to buy a hat that costs $29. That must be a pretty cool hat. How much change does she receive if she gives the cashier a $100 bill? Ooh. Okay, so hang on. So Crystal wants to buy a hat that costs $29. Okay? But in exchange for the hat, Crystal is handing a $100 bill. Okay? So I'm going to go hat plus 29 equals 100. So think about this. Crystal has $100 in her pocket. There's going to be an exchange for this hat. This hat costs $29. $100 is given. Crystal puts on the hat and is going to get some change back. Does that make sense? So hat plus the 29 equals 100. Subtract 29 from both sides. So Crystal gets the hat. And what kind of change? $71. Okay? So Crystal gets the hat and $71. And that's the exchange that just took place. Yeah.
Could you do 100 minus 29?
Absolutely.
Oh, sorry, 20
Absolutely.
to get X.
Yes. Do what?
To get X or H.
Yeah, I just made it as H. You can make it as X. You can make it as, some Greek letter. Make it as an emoji. That way you made it. You're like, dude, which emoji? The poop one? No. You're like, what's the poop one? That's the one that my daughter thinks is so funny. Like, look, Dad. Whatever. Oh, yeah. All right. Do we feel comfortable with number 17?
Yes.
Number 18. Oh, it's another story. Awesome. Stories, man. I hope this is like Harry Potter. Angeli, okay, was given $14 for her birthday. That's kind of a weird present. Here's $14. Oh, thanks.
I know, right?
She now has $53.
God.
How much money did she start with? Okay, so that's going to be, you know what? My variable. So she had some money in this piggy bank. Birthday present came rolling along, which was $14, yes? How much did she have now? How much did she start with? Okay, so we're looking for this one. That's our variable. So what should I do to both sides?
Minus 14.
There you go. So I'm going to subtract 14 doll hairs from both sides. He said doll hairs. So the starting amount of money that she had was $39. $39. All right. So how does this read in the context? The starting amount of money she had before her birthday gift was $39. But now she has $53 because she was given $14 for her birthday.
Sick.
That is the longest sentence in math so far. Any other questions from the homework? A-okay? Life is good? Somebody do me a favor, flip the light switch on back there. I teach the medical class, so I get what it is. So, did you get there yet? Sweet! Everyone get a solving linear equations number 4 note page. So this probably should go into your notebook prior to the page. So let's warm up. Oh, no calculator. Oh boy, oh boy, oh boy. Okay, there it is. -5 plus 12 minus 3. Help me out. What do we do? We're looking for an answer? Combine like terms. Okay? Combine like terms. -5 added to 12 is 7. 7 minus 3 is
4.
4. Some of you are going, but shouldn't I? Yes, you probably should. So if I add negative 5 and negative 3 together, you get negative 8, and then 12 minus 8 is also 4. That's the way to do it. So I could distribute over the parentheses first, or I could combine together what's inside the parentheses because they're already like terms. So let's combine first. What's 4 minus 10? Negative 6, and then negative 6 times 3 is how much? Negative 18. Bless you. Letter C, order of operations would suggest to do what first? Division. So what is 8 divided by 4? 2. And what's 2 added to 2? 4. Okay. Letter D, I could distribute the 3 over the parentheses first, or I could do the math that's taking place inside the parentheses first. So what is negative 2 added to 5? Negative 2 added to 5.
Positive 3.
Positive 3. So I have 3 times 3 minus 2. Order of operations says to do what next? Multiply. So that's 9. 9 minus 2 is?
7.
Done. Any questions on any of those? Feeling all right? Can I move on? Yeah. Here we go. All right. Solving linear equation. Solving two-step. Okay, so now we're going to be multiple steps. So things that we did with the one step is we created like a dotted line for the equal sign all the way down. And that means that what we do to one side of the equation, we have to do to the other side. Okay? You can't just do something to one side and forget about the other side. Because if it's equal, that means it's balanced. It's like a teeter-totter or some balance beam. In order to stay balanced, if I add 10 to one side, I have to do it to the other. If I divide by 6 on one side, I have to do it to the other. But things that aren't you have to do to one side and the other is if you could distribute over the parentheses first, distributing over the parentheses is not doing, you're not adding another step. You're doing the math that's already there. Okay? So, let's see what we do. The inverse, we can do this. The inverse of addition is? Subtraction, yeah. The inverse of subtraction is? Addition, all right. The inverse of multiplication is? Oh, you guys are awesome. Fridays are great. All right. Dividing by a number is the same thing as multiplying by the,
Reciprocal.
Oh, yeah, reciprocal. Reciprocal. I think I spelled it correctly. If I didn't, good thing we're not in grammar. When we solve an equation, our goal is to get x alone. What is x called sometimes? Variable. So to get the variable by itself. And then we also know that a lot of times that variable is x. Okay? It could be other letters as well, and as we said before, it could be Greek letters, it could be emojis, it could be, a tree or, a variable. You're identifying something that could be changing. Does everyone feel okay about these? So for the most part, X is kind of our go-to letter in math. I don't know why they chose to have X versus M or, I would like to see like lowercase l be, what we always solve for, just because, it never looks like a 1. Just kidding. Can I move on?
Why do we not use capital letters?
I don't know. I wasn't at that meeting when they voted on stuff. I'm sure we could, though. Definitely we could. All right. Can I move on? Anyone stuck? Moving on. All right. Our example. What is happening to our unknown number? Can you put this into words? What did we see? What did we first do to the number? What did we do second to? Now, let's work backwards. Okay, so let's just look at this. I want to solve this equation, so I'm going to do this. Is that okay? What does that pink represent? The equal sign. So what I do to one side, I have to do to the other, yes? All right, so when you are going through these types of problems, what you do to one side, you have to do to the other. And with these, a lot of times, you're actually working backwards in the order of operations. Let me say that one more time. We're working backwards in the order of operations a lot of times. You're undoing stuff, so if you're undoing, you're working backwards. Make sense? So if I'm working backwards with the order of operations, what would it suggest that we do first? Yeah. Add the 2. I like it. And again, I'm going to show all steps, and I realize some of you are like, dude, I get this. I understand that you get this, which is awesome, but I'm showing my entire thought process so you can follow along. So if I go ahead and do that, this 2 and this 2 are gone. And that leaves me 3x here. There's an equal sign. And then what do I have on the right side? 6. I just do the addition. Okay? So now that was my first step. So now I have a one-step equation left to take care of. So how are 3 and x being held together? Multiplication. What do you think I should do to both sides to get divide? So what I do on one side and that side. I like it. And I wind up with what for an answer?
2.
X equals 2. So x equals 2. Just pull off the side, circle it, and say good. So can you see why it's 2 steps? Here's my first step. Here's my second step. Okay? So 2-step means we're doing 2 mathematical operations. Remember, we're undoing it, so our order of operations will be backwards most of the time. May I move on?
Yes, you may.
Anyone still there? Anyone confused yet?
You may move on.
Moving on. Wait. Okay. Example number 2. Let's see. Hang on. Let's do this and we'll fill it out. Okay. That's my equal sign. Is it okay that my variable's on the right side? Sure. Absolutely. Okay. What do you think my first step would be? So I'm going to do this. I'm going to go -3, and maybe we'll put this. We subtract 3 from both sides. Okay, so if I go ahead and do that, that's going to give me 9 equals y over 3. What's my next step? Yeah, multiply both sides by 3. So I'm doing this, and I'm doing this. So multiply both sides by 3. Because it was division, so the undo of division is multiplication. So that cancels that. That looks like I get 27 is equal to y. So my answer will be y is equal to 27. Could I left it as 27 equals y? Yeah, it would have been totally okay. Okay? Feeling all right? Yay, name, kind of bay? Are we on the back side of the notes already?
Yep.
Sweet! All right, here we go. All right, let's have some fun. What are you guys doing? What? All right, well, put it into a location that we don't have to worry about. All right, round number 1, coming around the room. Mimi, shot it.
So you subtract 6,
Yeah, maybe. Subtract 6, bless you.
and then
So hang on, I got negative b is equal to -17, and then.
and then that's it.
No.
Do I want a negative variable, you think?
Yeah.
Plus b.
No. How do you think? Do what? Divide by what? Negative b? Well, that would give me 1 equals 17 over b.
-1.
-1? Oh, I like that. So if I divide each side by -1, what do you think? Because theoretically, there's a 1 right there, right? There's a 1 sitting right there. So I'm going to go whoop, whoop. And now b is equal to what?
17.
-17 or positive? Positive. Done. Love it. All right. Feeling all right? All right. Do I have another me? Wants to help? All right, me. Go ahead, me. What am I going to do to both sides? Subtract an 8? Yeah.
Wait.
Waiting. Why is it a subtraction? What's the 8? What is the 8?
8 is a positive.
8's positive. I like it. So that cancels. So I get -3y equals, still with me? What do I get? 6. All right, what's my next step? Divide by what? -3. Awesome. If I divide by negative, that'll change our sign. So what do I get? 6 over -3 is? -2.
Y equals -2.
Oh, you guys are so awesome. And there's so much thought and process. I'm so proud of you.
Thank you.
Thank you, sir.
You know, I used to think I was so bright because my dad called me son. Nah. All right. Number three. Me. It's making my.
So you
I like it. Add 7, add 7.
And then
And hang on. So I get this equals negative 31 added to 7. It's a negative answer. I know that.
Negative something.
Negative 24.
24. Sweet.
okay.
Then
you divide
by
4, negative 4.
yeah. If I divide by negative, does that change the signs?
Yes.
Yeah. So I get x is equal to
X is equal to 20.
6.
6. I'm dividing, right?
Oh, you
Dividing. It happens. It happens. X is equal to 6 because negative 24 divided by negative 4, it's going to be positive, and then 24 divided by 4. Are we okay? How are we doing? Oh, we're almost there.
We're doing awesome.
I'm doing awesome. Thank you. All right.
Minus 4.
Okay. I love it. Minus 4, and it's okay. The variable's on the other side, so I get negative 3 is equal to t over 3.
Times 3.
Why is it times 3? Help me.
Because you're dividing
By?
by 3.
Oh yeah, these are being divided, so the opposite of divide is multiply. So t is equal to negative 9. So I could write it like this if you'd like. Okay, it's your choice. Either way is totally fine. Oh, what's going on number 5? That looks a little different.
Oh, I know.
You just have to
What's going on right here?
You add 3
Multiply 7.
Why do I multiply 7 and not add 3 though? What's going on here?
The X and the 3 are on top.
Yeah, the x and the 3 is taking place. It's all on top and then on bottom. Question back there? Are you good? Yeah, baby. All right. So being that x minus 3 is already up on top, that means that the whole thing's being divided by 7. So I have to divide both sides by 7, or multiply both sides by 7. So that reduces. That leaves me x minus 3 on this side. What's 12 times 7?
84.
Yeah.
That's not up.
84. Help me out. Help me out.
Okay.
Adding 3, agree?
Plus 3.
Yes.
Plus 3, adding 3, I like it.
X equals 87.
X is equal to 87. You know, in 1987, that was my sophomore year in high school. 86, 87, yeah. Oh, yeah.
It would still be the same answer though if you added 3 sevens, right?
What's that?
It would still be the same answer though if you added 3 sevens, right?
No, not quite.
Well, because then
I see what you're doing.
multiply by 7 and still come out with the same answer.
Yeah, I see what you're doing. I think you might have gotten lucky on that one. So I'd realize that the whole top's being divided, so undo the dividing by multiplying first, and then.
That's what I added. I got 105.
Oh, so you added and you
Well,
got a
add
total.
3
Yeah, I got it.
sevens.
Oh, you're
I was
saying add-
3
Oh.
sevens.
I see. I can see that. Okay. Cool. Almost there. What did I do?
Oh,
Mimi, add 4. Good. Yay.
Yeah.
Add 4. Yeah. 2/3 m equals 6. What should I do?
Multiply by the reciprocal.
Oh, what's the reciprocal of 2 over 3?
3 over
3 over 2. You guys are awesome. Let's see. That cancel. M equals 3 times 6 is 18. 18 over 2 is 9. Or I could have went 2 into 6. 3 times 3 is 9. Oh, cool. This is so cool. What do we got? Yummy yogurt. You know what? We're going to do this one at a different time. I bet you we're going to be just fine. Guys and girls, you guys, few things. You did awesome this week. And yes, homework. So, but here's the nice thing.
Oh, that's great.
Here's the nice thing. So you have worksheet number 4A, and it's page 11 only. There's only one side. There's not a front and back.
Yeah.
Are you passing it out?
No, it's in your book,
In our book or
What the heck?
your packet.
I don't
that
see
you gave us?
I didn't give you any packet. You need to buy the book if you
Oh,
don't
yeah.
have a packet.
Now I have.
Yeah, so it's page 11, worksheet 4A. It's only one side. The textbook is different than the packet that you bought from the bookstore. The textbook is just for you to use as a guide if needed. But, sir, yeah.
What's this deal?
Monday.
But this is the stuff we bought in the